Okay, so we want to find the equation of a tangent line at a specific point. Okay, so we should automatically be thinking about differentiation to give us the gradient of the tangent, and then we have the point, so from there we can get the equation. Okay, it wasn't exactly clear on which function how the function is written here. We're going to be using implicit differentiation, and since I am assuming you're fairly new to that concept, I suspect that the first one is the function that we're going to use because it's a bit of an easier example. And so let's say that that's not the one we're going to use. So we're going to use the first one. Okay, so what is implicit differentiation? I put an example here to illustrate what it is. We might forget about this middle step here. But in a simple example, so we have y equals x squared. What's actually going on? Well, we're differentiating both sides. So we have y becomes dy, right? The derivative of y and dy. Derivative of x squared is 2x dx. This is actually what we're doing, but we usually skip this step. We jump right to the last step because this one's fairly easy. To get to the last step, we just divide by dx. And so we have this familiar thing, dy dx equals 2x. Okay, that's the derivative of y in terms of x. All right, so that's what we're going to do here. Implicit differentiation, we're going to differentiate both sides. Okay, so here's our function. Okay, we're going to differentiate that. No, sorry, here's our function. Yes, there is our function. Okay, and we're going to differentiate both sides. Okay, so the first piece is pretty straightforward. Differentiating this, we get 4x cubed dx. This one has an x and a y in it, so we're going to have two pieces. First, we're going to differentiate in terms of y. All right, so basically we have what could be thought of as a constant in front of the y. Okay, so it's that times the derivative of y, which is dy. So we have this 3x squared dy. Now we have to differentiate this in terms of x. Okay. Again, we can think of the y as part of a constant, so grouped with the 3. The derivative of x squared is 2x, so we have 2 times 3 times y. That's 6 times y times x times dx. Okay. This one just in terms of y, so pretty straightforward, minus 14y. Okay. For these middle terms, go through it on your own, work it out, write it on paper, and make sure you can match what I've got there. Okay, now it's just a matter of rearranging this, and again, work that out on paper, make sure you agree with this. You should end up with dy over dx equal to this. Okay, I skipped a lot of the algebra here, but pause the video, work it through, make sure you get what I'm getting here. All right, and then we evaluate it at 1 and 2, and you get this number. That's our gradient. Okay, and then we just need the equation of the line, so we'll use this. So y minus the y value, which is 2, times equals the gradient times x minus the x coordinate there, and then you put it into standard form. There's our equation. All right. Now, it's done, but I always like to check and make sure that it makes sense. Desmos is my go-to tool, and so I put in the function and I put in the tangent line and see what it looks like. Okay, so the red one is the function, and the blue one is the tangent, and it looks pretty nice because there's the point 1, 2. Okay, you can see that my tangent line is in fact tangent to the curve at that point, so I feel pretty good about it. All right, again, go through all the algebra. You gotta do that, and you'll see how it all makes sense. Okay, I hope that was helpful.